Good morning, everybody. Wait, let me go back. Let me say it again. Good morning, everybody. All right, happy Halloween to you. So, if you remember, my name is John Fellenstein. I work at the University of Akron, but my stage name, Professor Polymer, okay? Today, I brought a colleague of mine who goes by the stage name of Manny Monomer.
Hi, everyone.
This is really Dr. Ruel McKenzie, and he is a polymer engineering scientist, okay? So he's on faculty at the university, really smart guy, really cool guy, and he's gonna give us some really good insights into some of the things that we're doing today, okay? So, are you ready for spooky science? All righty. Well, I heard that this building used to be a museum of some sorts. Is that true? Yeah. Okay. So, and I think I also heard a rumor that there might be some ghosts in the building. Do you think there are ghosts here as well? Yeah? Well, but anyway, we're gonna try to call one of our ghosts out of hiding today, so you might be able to see it, okay? And I'm gonna need Mr. Coach Cruz to come on up here as well, okay? So we've got these really interesting devices here, and we call these singing bars, okay? Now we're gonna use these, and it's gonna be really, what's the word? It might be uncomfortable for some of you guys, all right? Because they make funny noises, all right? But I think if we make the noises correctly, we might be able to get the ghost to come out of that bottle. I think he's trapped in there, okay? So that's our goal, all right? And I know Coach Cruz has been doing a lot of practicing, so he has this down just right. So, you hear that? So Coach Cruz, go ahead and make your sound bar sing. Oh my, all right. And then I can make mine sing too. Sorry about that, Nate. And then, what about you, Dr. McKenzie?
I'm getting there.
Okay.
It's a tiny hum.
Maybe a little slower. So we have to have something that's a little sticky on our fingers, and we're using rosin, which is the same stuff that you would use on a violin bow. Okay. So let's see if we can all get it going here, as loud as possible. Is it working?
Getting there.
You want us to keep going? Do you like that?
There you go.
There it is. Oh. Here comes the ghost. Whoa.
Bye, ghosts.
They don't stick around for very long, right? They don't really hang around. All righty. Awesome. That was fun.
So maybe a little science while we transition to the other one. So the reaction we just did was actually just a decomposition reaction. What we had in our ghost jar was hydrogen peroxide. Does anyone know what hydrogen peroxide is? Few hands. That's actually a homework problem for you. Go home and see what you can find that has hydrogen peroxide in it. So it's actually a very strong oxidizing agent, and it wants to break apart. But because there's so much energy built into it, all we had to do was put some metal beside it. And what this metal does, it actually catalyzes the breakdown of hydrogen peroxide. So the ghosts that were flying away were actually just water and oxygen. So not too scary, and hopefully very good ghosts as well. Thank you.
I think that they're probably just going to hang out in the rafters for a while. That's what I think. Okay, well, let's see, what's next? Electric Pickle?
Next is...
I think we have that, right?
The toothpaste.
Oh, we're going to need the toothpaste. Oh, okay,
Yeah.
awesome. Coach Cruz, we need a volunteer. Yeah, just one.
So we need a volunteer to help make some toothpaste for an elephant.
What's your name? Kanaya, nice to meet you. Come on over here, okay? We're going to get you some safety glasses as well.
Hi, Kanaya.
Yeah, you're wearing regular glasses, but we want you to wear the safety glasses too. So what I'm going to do is put my glasses down here, put on my safety glasses like this, okay? Okay, so in this big flask, what we're going to do is we're going to mix up some chemicals, and we're going to make another reaction, okay? So like similar to the last reaction, but it's going to be a lot more fun and a lot more visually appealing. All right, so what we have, once again, we have, oh, I forgot to pour those in there. Okay, so we have hydrogen peroxide in 2 of the bottles, and we have potassium iodide in 2 of the other bottles. So what we're going to need you to do, first of all, I thought I had those filled and I didn't. Oops, it's okay. So we're going to fill this because we need a specific amount. Okay, I'm out of that. So I need this one now. Okay, your name's Kanaya, right? Mm-hmm. Kanaya, go ahead and take the first bottle, okay, and pour it into the big container. Alrighty. Do the same with the second one. Okay. Let's add some food coloring.
How many drops?
Oh, as many as you want. Okay, swish that around a little bit. Okay, very good. Now we're going to ask you to add some soap as well. That whole container can go in. Swish that around a little bit as well. Okay, a little bit of bubbles in there, right? That's good. Okay, so this is where the fun starts. All right, let's get this out of the way. I'm going to have you pour one, and I'm going to pour one. We're going to move this just a little bit. And let's get everything else off the table. Are you ready? Okay. So on the count of 3. 1, 2, 3. Whoa! Whoa! Whoa!
Wow.
Did all of yours go
That's
in?
a lot of toothpaste.
So what do you notice coming off of this? Yeah, put your hand up there. Don't touch it though. It's pretty warm, isn't it? Yeah. Okay, Dr. McKenzie, can you tell us why it might be warm?
Oh, there's so many things going on here. First, I have to say, I've never seen an elephant brush their teeth before, but this will surely get the job done. So there's a couple things going on here. So last time I mentioned that hydrogen peroxide is a very strong oxidizing agent, and it wants to break down into water and oxygen. So when it finds the right material that allows it to do it really easily, it actually gives off a lot of energy. That's called an exothermic reaction, so that's why there's steam coming off. So it's actually quite warm. That meant that the potassium iodide helped really well in making this reaction happen. The cool part, I think, is really interesting, is that in the last reaction we did, it was only smoke. This time we made foam. So if you paid attention, one ingredient we put in was actually some soap. What the soap does, it actually acts as a surfactant to make the foaming happen. So when the reaction gets underway, all that surface tension makes really cool foam bubbles. And if you do notice, that's actually what's also in your toothpaste. Foaming agents, right? So this will actually work really well for an elephant, I believe.
Okay, we need someone to clean this up now. Just kidding, we're gonna get the coaches to do it later, all right? Don't worry about that. All right, what do you think? Pretty cool? Okay, so here's our next activity right here. This is called the electric pickle. Did you know that some food stocks can actually conduct electricity. Do you want to see if this pickle will conduct electricity? Okay, hopefully we won't blow any circuit breakers. All right, that's always a concern for us. So let's see what happens. We're going to plug it in, and just wait a minute. Fun, isn't it? It's like watching paint dry. Oh my goodness. Oh my goodness.
Oh wow, a light show.
Yeah. That's not really too exciting. That's about as exciting as it gets. So it is an electric pickle though. Look at that. Interesting. Okay. It's starting to smell bad. I think we're going to have Coach Cruz eat this when we're done. All right.
I think that was very cool, Dr. Polymer. I don't know about you guys. I've never seen my food light up before. So what actually happened was the pickle is actually a cucumber, right? If you tried this with a cucumber, would it work? No? Why? Why wouldn't it work? Any guesses? You can shout it out because I can't really see you. Over there. Yes, you. Because it's vinegar? Close. It's actually the salt. So salt is a very conductive material. When you get it in a solution, it actually is able to conduct electricity. So by soaking the pickle in just brine, aka salt water, when you connect that to a circuit, it makes electricity. And also a nice cooked meal.
Yeah, so I wonder if there are any other types of foods that would conduct electricity. What do you think? Probably, right? Right? Well, I'll tell you what, I'm going to tell you a story. When I was in 7th grade, I had to do a science fair project, and I actually made a hot dog cooker which was very similar, okay? So 2 nails through a board, and we cooked a hot dog on 2 nails, and we completed the circuit with a hot dog. So there must be a lot of sodium in a hot dog as well, okay? Any idea why it was yellow? Why was the pickle yellow? What do you think? The pickle's like metal. Well, I guess sodium technically is a metal, right? Yep. So yeah, it's the same thing like when you go out at night and you see the street lights and they're a little bit yellow. Those have sodium vapor in them, and sodium, by its signature, the way that it always burns yellow. Okay, and you'll learn that when you get into chemistry. All right. Okay, so we have anybody out there who likes movies? Yeah. What about? I like classic movies, like The Wizard of Oz. Does anybody like that movie? Okay. So my favorite character in The Wizard of Oz is the Wicked Witch of the West. How many people like her? You'll be sorry, my pretty, right? So at the very end of the movie, what happens to the Wicked Witch of the West? Yeah, so I think what Dorothy does is she throws a bucket of water on her, right? And then what does she do? She's like, I'm melting, right? Well, what's interesting about that is this is really how they did it, okay? So what they did, they had a large witch model, which was made out of styrofoam, okay? Which is the same stuff in these disposable coffee cups, okay? And it's mostly air. And exactly. So the water wasn't really water. It was this other material called acetone, which you can get as nail polish remover. So this is what happens when you mix polystyrene with acetone. Let's see if we can get this going here. I'm melting. Okay, that's how they did that special effect in The Wizard of Oz. Pretty cool, huh? All right.
Oh, that's a cool, spooky science. So the way that works, so styrofoam cups are actually a high surface area polystyrene. So that when the acetone hits it, because polystyrene is soluble in acetone, And because it's such a high surface area like this foam, there's lots of tiny holes and pockets in there. The acetone just easily sneaks in and says, hey, polystyrene, want to hang out for a while? And polystyrene says, yes. And so it solubilizes the polystyrene really quickly. And that's what happened to the poor wicked witch of the West.
Yeah, so those disposable coffee cups, they're really mostly air. And that's why they're such very good insulators. You can put something that's hot in it, and you can hold it, and it doesn't hurt your hands, right? You're not getting burned because the cup is a very good insulator. It keeps that heat away from you. Okay, it's going to give me just a little minute here to get this next thing set up. This is called the Giant Barbecue Burner of Science.
I like it.
But really, it's called the Rubens tube, okay? So there was a gentleman who, I think it was 1905, invented this. And what we have is we're going to have, some of you who were here earlier, you might have seen when I was testing it, we're going to have some flames coming out, but then we're going to do some other things with it as well. It's pretty cool. Let me get this rolling here. Wow. I know, right? So that's maximum pressure there. We're not going to go that high, though. We're going to make it a little bit lower, like that. So it works best in a room that doesn't have a lot of drafts. So I'm hoping that it will work in here, but we also have some spooky sounds that we're going to play through a speaker. So the way that this works, okay, so there's a big gas burner, okay? On one end is a flexible membrane and a speaker, okay? And what we're going to do is we're going to send sound waves into the tube itself, which are going to be reflected in the way that the flames react, okay? So let's see how this works. Those don't like to stay lit. What did you think of that? All right, so we have one more activity to show you, one more demonstration, and it's basically the way that scientists carve their pumpkins, okay? So we don't carve pumpkins with knives. We use science, and the best way to do it, I find, is with explosions. So I'm going to need a volunteer for this part as well, okay? Come on up here. Once again, we're going to do our safety glasses. Hi, what's your name?
Italy.
Italy. Put those on, okay, dear? All right. So, Italy, what I'm going to ask you to do is to pour some water into the pumpkin when I tell you, okay? So that little yellow cup is going to go inside. This is going to get loud, all right? So you might want to cover your ears. Okay? So the goal here, Italy, is for you to pour that water right into the yellow cup. Do you see it in there?
Yes.
Okay. Get this out of the way. Are you ready? Hold on, that's a little bit too much, maybe.
It's only water, everyone.
All right, go ahead and pour it in there. Carefully, you're going to see some steam and smoke come out. Get it right in that cup. Okay, very good. That's good right there. Okay. Let's move this, hold that, actually. So, are you ready for this? Okay, hopefully this is gonna work. 3, 2, 1.
Whoa! Woo! Look at that.
That's how we carve a pumpkin.
Wow.
Oh yeah. I told you it was gonna be loud. Careful, you're gonna see some steam and smoke come out. You're right in that cup. Okay, very good. That's good right there. Okay. Let's do this. Hold that.